All right, so I've got two more problems from 5.6, again on page 605 in your book. These two involve trigonometric functions along with our exponential. So let's take a look at 338. We're going to need to do a substitution here. We've got a product of two different functions. One function is e to the sine of x, and the other is cosine of x. The substitution should be obvious, but let's talk through it anyway. If we were to opt to use cosine of x as our u, derivative of cosine is negative sine, while there is a sine of x in the actual integral, it's not available. So it's actually e to the sine of x. So there's no sine of x to replace. You can't just have sine of x and just replace that with something else. It doesn't work. So the typical strategy is to find the thing that's in the square root or in the exponential or in the logarithm or something like that and make that your u when you have a product. So let's let u equal sine of x, which makes our du equal cosine of x dx, which we happen to have right there. So this easily transforms into the integral of e to the u du, which from our very first formula just gives us e to the u plus c. We make our substitution at this point, make e sine of x plus c. And again, when you take the derivative of that, it's e sine of the x again times the derivative of sine of x, which is cosine of x, and that's what we have. All right. This one's going to be similar. Here, what we have in the exponential is tangent. Derivative of tangent happens to be secant squared. So we let our u equal tangent of x, which makes our du equal to secant squared. We have that. We replace it. And that just gives us e to the u again, plus c. And now we substitute back. There you go.